everyone, today I'm going over notes 1.5. We're going to be solving systems of equations by graphing. This should hopefully be a review from Algebra 1. So let's start with the definition of a system of linear equations. It is a collection of two or more linear equations involving the same set of variables. So an example would be 2x plus y equals 7 paired with 5x minus y equals 10. So we have two equations and they have the same variables. They both have an x and they both have a y. When you are solving systems of equations, you're going to get three different outcomes. The first one is just one solution. That means that your two lines are only going to intersect at one point. You can also have something that has no solution. So if you have a system with no solution, that means you have parallel lines. They are never going to intersect. And your last option will be infinitely many solution. So that means that your two lines are actually the same line. So you can think of it as overlapping lines, same line, okay, let's get to this first example here. So solve the system by graphing. Just a quick reminder, when we're graphing, we're looking at y equals mx plus b. B is going to stand for our y-intercept, and m is going to stand for our slope. So my very first equation here, I'm going to start at 4 on your y-axis. 1, 2, 3, 4. And my slope is negative. So I'm going down and to the right, or I can go up and to the left. And I'm going to go ahead and connect my dots. My second line, I'm going to start at -5. And I'm going to go up 2 over 1. So I see that my two lines do intersect. So once I'm done graphing, I still need to write what my solution is to the system. So my solution is 3, 1. What does the solution represent? So the solution is going to represent your point of intersection. Right here. So when you're doing these problems, you guys need to graph the two lines, but you also need to tell me what the solution is to the system. Let's go ahead and try this next one. So this first line, I need to start up at 4, and my slope is a -1, so I'm going down and to the right, or up and to the left. Second line, I'm going to start down at -2, and I'm going to go up 2 and over 1. So connecting my dots, I see that I have one point of intersection, so my solution is going to be at 2, 2. Before we can graph something like number 2, we want to rewrite our equations so that way it's in y equals mx plus b. This is going to make it a little bit easier to graph. So I'm going to take my first equation and I'm going to subtract 2x to the other side. I'm doing this so y can be by itself. So I get y equals, you always want to write your x value first. So I get y equals negative 2x minus 3. And now I'm ready to graph that. Start down 3 on your y-axis, and we're going up 2 and to the left 1. We're going to connect our dots. Second equation. I want to add 6x to both sides. So I get 3y equals 6x plus 3. In order to get the y by itself, I want to divide everything by 3. So now I have y equals 2x plus 1. I'm going to start at 1, and I'm going up 2 and to the right 1, down 2 to the left 1. So my line should be something like that. My intersection is right here, so my solution is going to be negative 1, negative 1. Number 3, same idea. We want to go ahead and rewrite our equations so that way we get y by itself. So I want to subtract x, and I get a negative y equals a negative x plus 3. We still need to get rid of this negative, so I want to divide by negative 1. So I get y equals x minus 3. So I started at 3 on my y-axis, and I'm going up and right 1, or down and left 1. I want to go ahead and do the same thing for your second equation. So I'm subtracting 7x. I get negative y equals negative 7x minus 3. And now I'm dividing everything by negative 1. So I get y equals 7x plus 3. Start up at 3 on your y-axis, and you're going down 7 and over 1. And try your best to connect these 2 points. Don't forget to write out what your solution is, and that's going to be at negative 1, negative 4. So just a reminder, when you're doing these kind of problems, you need to graph the lines, and then you also need to tell me what the solution is. We are going to move on to a system of linear inequalities. So when you're graphing a system of linear inequalities, you're not just going to have a single point as an answer. A system of linear inequalities will consist of a set of solutions. And when you're doing these problems, you can think of where the shading overlaps. A couple things we need to know when we're working with these kind of problems is when to use a dashed line and when to use a solid line. So a dashed line is if you just have less than or greater than. A solid line is when you have the equal to. I'm going to add in some shading rules here. So when we have y is greater than or equal to, or just y is greater than something, you want to shade above. If it's less than or equal to, or just less than, you want to shade below. I'm going to make you a little key on the side here that helps you understand what is above and what is below. So if I have a line going this way, a positive line, above is right here and below is here. If I have a line going this way, so a negative line, this would be considered above, this would be considered below. And the last type of line we have is a horizontal line. Here is above, here is below. All right, let's try a few of these. If you have two colored highlighters or colored pens or pencils, that's going to come in handy for these kind of problems. So you might want to grab those. So this first line, since it has the equal to, I know it's going to be a solid line. My second line is going to be a dotted line. So you want to graph this just like you normally would. So I'm going to start at 3, and I'm going to go down 5, and to the right 1. And I'm going to connect with a solid line. Since the symbol is greater than or equal to, I'm going to shade above this line. For right now, you just want to do a light shading. Now my second line here is just going to be a horizontal line, and it's going to be right at -2. Make sure you're doing a dashed line. This is also greater than, so we're also going to shade above. So you're just doing a light shading. What you're looking for your final picture is where your shadings overlap. So we're looking at where's the pink and where's the blue overlapping, which is going to be right here in this top corner. So that's what I want you guys to now shade in really, really darkly. And you're going to erase the shading that's outside the overlap. If you can't erase it because you're using highlighters, just make sure you're making the overlap really, really, really dark. You can also write next to it that this is the solution set, and that will show me where your overlap is. So this means that if I pick any point in this solution set, it's going to make a true statement for my equations. Let's go on to number 5. So my first line here, I know it's going to be dashed because there's no equal to. And my second line will be solid because of the equal to. So my first one is just up at 3, and it's a horizontal line. It's now saying less than, so we are going to shade below this line. So just do a light shading below the line. My second line, I'm going to start at 1, and I have a slope of -1. So I can go up and to the left. I can also go down and to the right. And that's going to be a solid line. And check your symbol. If it's less than, then you're shading below. So below is going to be right here. And again, you're looking for where it overlaps. So right here is where I see my blue and my pink overlap. And I want to erase everything else. Again, if you can't erase it because you're using a highlighter, you can go ahead and point to the overlap and write solution set. So for these kind of problems, you guys aren't giving me a point for your answer. Your picture is your answer. So just make sure you're double checking your shading. Okay, let's go ahead and do number 6. Number 6 looks a little different than 4 and 5. We're going to start by rewriting our inequalities so that way y is by itself. So I want to subtract 4x, and I get 3y is greater than -4x minus 6. And then I'm going to go ahead and divide everything by 3. So I get y is greater than -4/3 x minus 2. Let's go ahead and graph that. So start at -2, and we're going to go up 4, to the left 3. You can also go down 4, and to the right 3. and that is going to be a dashed line. Since it's greater than, I'm going to shade above my line, which is right here. Now let's look at our second inequality. So we're going to start the same way. We're going to subtract the x. Now we're going to divide by a -3. Thinking back to Algebra 1, when you guys divided by a negative number for inequalities, you need to remember to flip your sign. So I now have y is greater than or equal to 1/3 x plus 3. I'm starting up at 3 and I'm going down 1 and to the left 3. Or up 1 and to the right 3. And that's going to be a solid line. My symbol is greater than, so I need to shade above, which is right here. You're looking for where your shading overlaps. So the overlap is right here, and you want to erase everything else that's not part of that. You can also go ahead and color it in really darkly so I can see where your solution is, or you can go ahead and write solution set and point to the overlap. So again, just make sure when you're doing these problems, your answer is not going to be a point, your answer is going to be a picture. All right, thank you guys for watching.